Okay guys, today we'll try to run 30 billion parameters model of Qwen3-Coder, which is 70.2 gigabytes into 8 gigabyte NVIDIA 5070 card. We'll do this with the help of Llama.cpp TurboQuant. As you can see, TurboQuant is coming from Google research scientists. With the help of quantization algorithms, are achieving massive compression for LLMs and vector search engines. If you're interested, you can read the paper and the explanation. In short, this will allow us to run the model. Let's see how we'll do it. So, for example, from this repository, we can clone it. And here I've done, for example, using git clone and then the name of the GitHub link. I've done this. And inside of this directory, I have the files from the repository. The next thing is that we would like to switch to the feature TurboQuant KV cache branch. We can type git switch and the name of the branch, or just git checkout and again feature and then TurboQuant KV cache. Where is the implementation of the algorithm? From then on, it's required for you to have installed CUDA. So you go to NVIDIA developer and then you need CUDA toolkit. So you choose the operating system, you download and install the toolkit on your system. Next, when it's installed, you would like to run the 64 bits of cross tools command prompt for Visual Studio. And here we are in this prompt. From there, we are using CMake to prepare the code for compilation, and to build the release for it, we'll use CMake build, and then using the configuration release file, we'll be having all the executable files built for us. If you encounter certain errors, you can try to add the parameter ninja that will stop checking for external build tools and will make the compilation successful. Of course, afterwards you need again to run CMake build for the release. The point is, when we type Llama server, to be able to run this command, and actually it's hidden in the directory build, and then inside we have bin directory, and here all those executables. And if we just repeat Llama server, it will start running from here. Okay, now to the parameters. So I'll just paste one long line explaining the parameters. In the beginning is the executable, creating a server, then is the path towards the model. You can of course save it in a different place. This is directly from the cache, from the Hugging Face. So as you can see, I'm using the 30 billion parameters model. Then I'm setting up a context size. You can increase the context size, of course. And those two parameters are actually cache type K and V that are essential for the TurboQuant to work. Afterwards, it requires the fast attention to be turned on. We are locking the memory not to be disturbed by other processes, which will cause it slow down. The next two parameters are more experimental. So the NGL is to offload layers entirely on the GPU. This is actually the preferred way to do it, because I noticed when I am experimenting with values here, with lower values, somehow it's quite difficult to pass the exact amount of RAM that will not cause a bottleneck and extensive copy from the GPU to the CPU, or from the faster GPU RAM to the normal one. So this will automatically choose the memory for you. And the next parameter, you can also replace it with the number of threads with -t parameter. So if you have, let's say, at 8 threads, you can type -t8. Here I have experimented and 20 works quite okay. For this machine, it has 20 cores and it fully utilizes them. In case you'd like to use less CPU power, you can lower this number. Okay, so let's load up the model. And as you can see, we have one video coder device with that much amount of RAM. And then we're trying to fit a quite bigger model into it. For this operation, we're offloading parts of the model to the CPU. And here are the buffers. Of course, after everything is ready, you should be able to have the server listening on localhost. And after the initial prompt, you can use it as a code helper. Here in Visual Studio Code, using this configuration, or actually I'm using OpenAI schematic of accessing the model. If you'd like, we can try running it. It's quite fast, and I'll show you, of course, the CPU usage. So initially it takes some time, but if I go here to performance, you'll see how the CPU usage will increase with the time. Here is the NVIDIA, and we have 7.7 gigabytes used from its memory. And now already the spike of the CPU until it reaches probably 90%. And here is the real-time generation. It's, for my needs, it's quite fast, considering that this is a quite big model. So it generates its content successfully. I'll stop it for now. And I'll show you this table where I'm comparing the 9 billion coder model with the 30 billion parameters one. So here are the tokens per second of the same task running on both of the models. And of course, we have around 4 minutes here waiting time on the bigger model. If you would like something fast, of course, you can use the 9 billion one for small coding tasks or tasks requiring small changes. But for architectural changes or code refactoring and optimization, this big model is way better. The 9 billion ones also is good if you are creating small mockup tests. So those are the numbers. If you have any other experience, I encourage you to write so in the comments. And if you like the tutorial, you can subscribe to the channel for more. Thank you.